Hello students, this is Lalika from Learn Guru classes. So today we are going to start with class 9 NCERT Science, the first chapter, that is matter and its surroundings. So in this video we will try to cover the physical properties of matter, and I assure you that after watching this video your concepts about physical properties of matter will be very clear. So with this note, let's begin our class. The first and foremost question that arises in our mind is that what is matter? We see so many things around us. The food that we eat, water, plants, animals, everything is made up of matter. If we consider a table has certain mass, right? And it occupies space. Water, if we see, water also has certain mass and occupies space. So any object in the universe that occupies space and has mass is termed as matter. Now, matter has certain physical as well as chemical attributes, and we are going to study physical properties of matter. So let's get started. Before digging into the physical properties of matter, you should know what is the nature of matter. So is it continuous like a block of wood, or is it particulate in nature like grains of sugar? Now if we just hand a grain of sugar, place a grain of sugar in our hand, we see that it occupies space in our hand as well as it has certain mass, though very negligible mass. So we can say that according to the definition of matter, that it is a matter. Okay. Now if you break this grain of sugar, okay, it consists of 1.1 quintillion molecules of sugar. So 1.1 quintillion means 1.1 into 10 to the power of 18 molecules of sugar. So just imagine the grain of sugar is itself very small, and this can even be broken into 1.1 into 10 to the power of 18 molecules of sugar. So how this small grain of sugar can be broken into smaller and smaller and smaller particles. So from this we can say that matter is particulate in nature, or matter is made up of particles. To have a clear understanding about the particulate nature of matter, let's try to demonstrate it with the help of an experiment. Now coming to the experiment, we have to take 100 ml of water and 2 crystals of potassium permanganate. Now what is potassium permanganate? It is basically a compound consisting of 1 atom of potassium, 1 atom of manganese and 4 atoms of oxygen. Okay, so it is basically a purplish black crystalline solid which on adding to water turns water into pinkish color. So coming to the experiment, let's take 100 ml of water and just dissolve 2 crystals of potassium permanganate into it. So immediately the water turns pink. So 2 crystals of potassium permanganate is itself very small. Now it has the capacity to color a large volume of water. So what does that indicate? It indicates that 2 crystals of potassium permanganate has many particles that is capable of coloring the water pink. Now to understand even further, let's take 10 ml of the solution of potassium permanganate solution. Let's take 10 ml and put it into a clear 100 ml water. Okay. Then also from the picture you can see 10 ml we are taking and we are adding it into 100 ml of clear water. Now what do we see? Now the water turns pink. and this process is continued, and at every process we see the water turns pink, though the color of pink is not very intense as the first case. So what does that indicate? How much amount of potassium permanganate we have used? Only 2 crystals of potassium permanganate we have used, and this is capable of coloring a large volume of water. So from that we can say that potassium permanganate is a matter, and this matter consists of many tiny particles that has the impact of coloring a large volume of water. So from that we can say that matter is made up of particles. There are 3 physical properties of matter. First one is particles of matter have spaces between them. Second property is particles of matter are continuously moving, and the third property is particles of matter have force of attraction between them. So let's study them one by one with real life examples. The first property of matter is that particles of matter have spaces between them. So to understand this, let's take one real life example and try to demonstrate it. For this, we are taking a glass of water and a teaspoon of salt. Now, you try to notice the level of water. Now, what we do? We add salt into the water and try to stir it so that the salt completely disappears in water. Now try to notice the level of water. Now, is the level of water affected? No, it's just the same. But what has happened? Where has the salt disappeared? What has happened to the salt? The explanation is matter consists of particles. So water is matter and it consists of particles. So the water particles have spaces between them, and when salt is added to water, salt breaks into particles, and these particles occupy the spaces between the water particles, and thus salt completely dissolves in water, and that's why the level of water is not being affected. So from this we can say that particles of matter have spaces between them. So if we see here, the blue balls represent the particles of water. So if we see the blue balls, that is the particles of water have spaces between them. The red ball represents a single crystal of salt. So when this single crystal of salt is added to water, this breaks into several small particles of salt that is represented by small red balls, and this absolutely fits into the spaces between the water, and thus we can say that salt completely dissolves in water, completely disappears in water, and thus the level of water does not rise. The second property of matter is that particles of matter is continuously moving. Have you ever noticed that when you light an incense stick, the fragrance of the incense stick spreads throughout the room? Or if you add a blue dye in a glass of water, the glass completely turns blue. Why is it so? The particles of the matter have an inherent capacity to move, that is, they have kinetic energy. Thus, we can say that when we light an incense stick, the particles of smoke in the incense stick moves and mixes with the particles of air, and thus it leaves a beautiful fragrance to the surroundings. Similarly, in case of water and blue dye, whenever we mix any blue dye in water, the particles of blue dye, the particles of matter present in the blue dye mixes with the particles of water, and thus the water turns blue. So from this we can conclude that the particles of matter have kinetic energy, and thus the particles of matter are continuously moving. Have you ever thought what will happen when you add a blue dye in a hot water? Will it take the same time to turn the water blue as that of the normal water, or will it be faster? So let me tell you, the reason behind is that when you heat water, the water gains more kinetic energy. That is, it gains more capability to move faster. So this is the reason why when you add blue dye in a hot water, the particles of blue dye mixes very well or very faster with the vigorously moving particles of hot water, and thus it turns the water blue with lesser time. The next property of matter is that particles of matter attract each other. So for this, let us take one wooden table, some pieces of chalk and a hammer. So let us try to break both the wooden table and the pieces of chalk with the help of a hammer. Now you tell me which one can be broken very easily. Obviously, pieces of chalk. So why is this so? The force of attraction is different in different substances. In case of a wooden table, the particles of wood are placed very close to each other. That is, they have a very strong force of attraction. So even if you apply a force with the help of a hammer to break it, it can't be broken so easily. Similarly, in case of pieces of chalk, the particles are placed far apart from each other compared to that of the wooden table, means the force of attraction is little less, and so for this, even if you apply a small amount of force, you don't need a hammer. Even if you break a chalk with your hand, you can easily break it, because force of attraction in pieces of chalk is not that strong. What is the force of attraction of particles in water and gas? In water, the particles are less close to each other. They are far apart, means they have very less force of attraction, and they has the ability to move faster. In gas particles, the particles are even far apart from each other or loosely arranged, and so they have more amount of kinetic energy and least force of attraction. If we compare the arrangement of particles in a wooden table, chalk, water and gas, we see that in a wooden table, the particles are very close to each other. That is, they have lesser kinetic energy and more force of attraction. In case of chalk, the force of attraction is little lesser. They are less close to each other. In case of water, the particles are loosely arranged. That is, they have lesser force of attraction and they have more amount of kinetic energy. In case of gas particles, the particles are loosely arranged or loosely packed, they have the ability to move anywhere and everywhere. That is, they have more kinetic energy and they have least force of attraction. So this is all about the properties of particles of matter. So next class we will see what are the states of matter. So if you find this video helpful, please subscribe to Learn Guru classes, like, comment and share it with your friends and relatives. So thank you so much. Bye-bye.